Hey everyone, ready for a deep dive into something incredible, 3D printing. We've got a ton of amazing sources you've sent us, articles, research, your own notes, the whole works. We're talking about taking a design on a computer and turning it into, well, a real hold-it-in-your-hand object.
And it's not just a futuristic fantasy anymore. It's revolutionizing everything.
Yeah.
Healthcare, aerospace, you name it. Even, building houses. What's really fascinating is how this tech is changing the game, not just for, engineers and designers, but for all of us.
So let's break it down, starting with the basics. 3D printing, we hear it everywhere, but what does it actually mean?
Right. Most people call it additive manufacturing. Think of it this way. Instead of chipping away at a block of marble, you're building something up, layer by layer, kind of like those Legos we all played with as kids.
Okay. Building a statue from the ground up. I get it. So less waste, more sustainable. I think Jörg-Owe, one of our key sources, he's a big proponent of that aspect.
Yeah, exactly. Less waste is a huge plus. But what I really get excited about, is the complexity and detail you can achieve. 3D printing lets you create designs and shapes that would have been, impossible before, or crazy expensive to make.
So we're talking about changing the way we even think about design. Now, I know there are different techniques involved in 3D printing. Can you walk us through those?
Okay, sure. First up, you've got fused deposition modeling, FDM. It's the most basic one. Imagine squeezing toothpaste from a tube, but instead of toothpaste, it's melted plastic, and it's building up a layer, a very thin layer at a time.
Okay, the toothpaste analogy, that works. So FDM is for the simpler designs.
Yeah.
What about if you need something more, precise, super detailed?
Then we're talking about stereolithography, SLA. It's like curing nail polish under a UV lamp. But instead of nail polish, you have liquid resin, and a laser hardens it layer by layer. It's amazing for super smooth, intricate parts, medical models, prototypes, that kind of thing.
Got it. SLA precision in detail. So what about those really strong, complex designs? How does 3D printing tackle those?
Well, that's where selective laser sintering comes in, SLS for short. Picture this, a laser, a powerful one, fusing a sandcastle together, grain by grain. Instead of sand, you're using powdered materials like nylon or even glass beads. It's perfect for really intricate shapes and super durable parts.
Wow. SLS, the heavy hitter for tough jobs. What about metal parts? Is 3D printing even able to do that?
Oh, absolutely. That's where direct metal laser sintering comes in, DMLS, that's the acronym. It's a high-tech blacksmith using a laser to fuse metal powder, incredibly strong metal parts, really intricate details, almost no waste compared to traditional methods. It's revolutionizing industries like aerospace, where they need parts that are both strong and light.
So DMLS, it's like magic for metal. So we're not just talking about simple plastics anymore. What other materials are being used in 3D printing?
Right. The material landscape is exploding. High-performance polymers like PEEK for parts that can handle extreme heat and stress. And, get this, even metal filaments are starting to emerge, making metal 3D printing much more accessible.
Wow, that's incredible. It seems like 3D printing materials are becoming more diverse and sustainable. I know Jörg-Owe has written about that.
Absolutely. And the push for biocompatible materials, that's really fascinating. Imagine printing custom implants or even, bioprinting tissues. That's where this is all heading.
Mind-blowing. So we've got these amazing applications, but let's bring it back down to earth a little bit. Why should our listener, the average person, care about all this 3D printing stuff? How does it impact their everyday life?
Well, think about it this way. Imagine ordering a custom-designed phone case that fits your phone perfectly. Or shoes, made to your exact measurements. That's the kind of personalization 3D printing offers.
Wow, yeah. So no more one-size-fits-all. 3D printing could completely change the way we shop, the way we create personalized products.
Exactly. And think about the speed, the efficiency. It lets companies prototype things so much faster, test and refine designs in a fraction of the time. That's huge in today's, fast-paced world.
So basically, it's compressing the design cycle, getting from an idea to a finished product much quicker.
Exactly. And that speed, it translates into other areas too, like custom medical implants, perfectly tailored to a specific patient. They can do that incredibly quickly. It's pretty remarkable.
Okay, so we've got personalization, speed, efficiency. It sounds almost too good to be true. Are there any downsides to 3D printing?
Well, of course, like any groundbreaking technology, it has its challenges. Cost is one, especially for the really high-end stuff. And getting that perfect surface quality, that's not always easy, especially with certain techniques.
It's not a magic wand you can just wave over every manufacturing problem.
Right. And, in fields like aerospace or healthcare, safety is everything. Strict quality control, certification, it's non-negotiable. And that can add to the complexity and the cost.
Yeah, of course. You wouldn't want a plane court failing because of a 3D printing problem.
Exactly. Jörg-Owe, he's written a lot about this, finding that balance between speed and precision. Sometimes, trying to produce things faster means sacrificing quality, and that's not always an option, especially when, lives are at stake.
So you have to weigh the pros and cons for each specific use, right?
Right. But the good news is the 3D printing world, it's always evolving, coming up with ways to overcome these hurdles.
That's great to hear. So what are some of the exciting developments happening right now? Like what's on the horizon for 3D printing?
Well, one area that's just exploding is 3D bioprinting. We touched on it a little earlier, but it's worth, going a bit deeper. Imagine printing functional human tissues, organs even. It could completely revolutionize medicine.
Sounds like something out of like a sci-fi movie.
It's closer than you think. Addressing the organ donor shortage, creating treatments perfectly matched to a person's DNA, regenerating damaged tissues. That's what we're talking about here.
It's pretty mind-blowing stuff.
It is, and the advancements don't stop there. Another game changer. AI and automation. They're being integrated into 3D printing, optimizing the whole process from design to post-processing. It's making it more efficient, more reliable, and, much easier to use.
So AI is taking 3D printing to a whole new level, making it smarter, more accessible.
Exactly. It's like having an expert by your side guiding you through all the, complexities. Jörg-Owe, he really emphasizes this in his writing. AI is democratizing access to 3D printing, empowering a new generation of creators.
That's exciting. It sounds like we're on the verge of like a 3D printing revolution. But let's, keep it real for a second. Let's talk about some concrete examples. How is 3D printing actually being used today in different industries?
Sure. Let's start with aerospace. They're using 3D printing to create lighter, more fuel-efficient components for aircraft. More sustainable, more cost-effective air travel. That's what we're talking about.
3D printing helping to make planes better for the environment and our wallets.
Exactly. And then there's the automotive industry. 3D printing custom parts, even entire car frames. More personalized designs, faster production times.
So it's driving innovation in the air and on the road. What about in medicine? I know we talked about bioprinting, but are there other applications too?
Absolutely. Personalized implants, prosthetics, surgical guides. 3D printing is transforming healthcare, and like we said, those bioprinted tissues, they're making incredible progress in, regenerative medicine.
So 3D printing is really changing healthcare, offering new hope for patients. What other industries are being impacted?
Well, we can't forget about construction. We're talking about building entire houses, structures with 3D printed concrete, revolutionizing affordable housing, creating sustainable building solutions. That's what this is all about.
Wow, 3D printed houses. That's amazing. It really seems like 3D printing is only limited by our imagination.
Yeah, exactly. And these are just a few examples. Jörg-Owe, he always points this out. The true power of 3D printing is its ability to empower people, communities. It's not just for big companies anymore. It's giving people the tools to create, to innovate on their own terms.
That's powerful. So 3D printing is making manufacturing accessible to everyone.
Exactly. And that accessibility, it's fueling creativity, innovation everywhere you look. People are using 3D printing to solve everyday problems, personalize their stuff, even start their own businesses.
It's like giving everyone the power of a factory, right, in their own hands. Amazing. We've covered so much, the technical stuff, the amazing applications. But I'm curious, what are the challenges that 3D printing still faces? And what does the future hold for this technology? I mean, what's next?
Well, we've talked about all the incredible potential, but it's important to remember that 3D printing, it's not a perfect solution. There are still some hurdles, some challenges that need to be tackled.
Yeah, for sure. So what are some of the, roadblocks that we still need to overcome?
One of the big ones is quality and reliability, especially as 3D printing moves into, more demanding applications. Think about things like aerospace or medical devices. We need to be absolutely sure those parts are going to work perfectly every time.
Yeah, it's not like printing a phone case. The stakes are much higher in those industries.
Exactly. So we need to develop really robust, quality control systems, standards to make sure that 3D printed parts meet those, super high requirements.
So basically, it's about building trust, confidence in the technology, especially when safety is paramount.
Right, exactly. And then there's the issue of scale. Right now, 3D printing is mostly used for prototyping or like small batch production to really, unlock the full potential. We need to figure out how to mass produce things with 3D printing.
So it's like moving from a craft workshop to a full-blown factory.
Yeah, something like that. And that requires investment in infrastructure, research, training. We need a whole new generation of experts who know how to design, operate, and maintain these, sophisticated 3D printing systems.
There's not just the tech itself, it's the whole ecosystem that needs to grow and develop.
Exactly. And then, there's materials. We've seen a lot of progress, but the range of materials we can use for 3D printing, it's still pretty limited compared to like traditional manufacturing.
So we need more options, basically.
Yeah.
We need to expand the material palette to make 3D printing even more versatile.
Right. And, researchers are working on that, experimenting with new polymers, composites, all kinds of stuff. And AI, machine learning, they're playing a big role here too.
You mentioned AI earlier. How is it being used in material development?
Well, AI algorithms can analyze huge amounts of data about materials, like their properties, how they behave under different conditions. And that helps researchers identify promising new materials, optimize them for specific 3D printing applications.
So AI is like speeding up the process of discovery and innovation.
Yeah, exactly. And it's not just about discovering new materials. It's also about using the ones we already have more efficiently. AI can help with that too. Reduce waste, improve sustainability, all of that.
Right. Making 3D printing even more eco-friendly. So speaking of sustainability, how is 3D printing contributing to, a greener future?
Well, one of the biggest benefits is that it reduces waste. Additive manufacturing, by its very nature, it uses only the material that's needed to create the object. So you're not left with a bunch of, leftover scraps like you would with traditional methods.
So it's inherently more resource efficient.
Exactly. And 3D printing also allows you to produce things locally so you don't have to ship them all over the world, which reduces transportation costs and emissions.
Right. Less reliance on those big polluting cargo ships.
Exactly. And there's even potential to use 3D printing for upcycling and recycling. Researchers are looking at ways to turn waste plastics into new products.
Wow, turning trash into treasure.
Yeah.
That's a great example of how 3D printing can support a circular economy.
Yeah, absolutely. And, as the technology keeps improving, we're going to see even more innovative and sustainable applications.
It's exciting to think about all the possibilities. So as we wrap up this deep dive, I want to ask you a big picture question. What do you see as the ultimate impact of 3D printing? How is it going to change our world?
Well, I really believe 3D printing has the potential to fundamentally change the way we design, manufacture, interact with the physical world. It's about empowering creativity, innovation, sustainability. And it's already making a huge impact in so many different fields.
So we're entering a new era of manufacturing and design. More personalized, more efficient, more sustainable.
Exactly. And like Jörg-Owe says, the real power of 3D printing, it's not just about the technology itself. It's about the human ingenuity it unlocks. It gives us the tools to solve problems, create beautiful things, build a better future.
That's a great note to end on. To our listeners, thanks for joining us for this deep dive. We hope you've learned something new and that it's, sparked your imagination. The world of 3D printing, it's full of wonder, and we can't wait to see what the future holds.
Yes. Thanks for listening, everyone.